Hello, this is Ice Ice Ninja here, and I'm posting something that's a little bit different from the history that's been on my channel. But this is, I guess, I've grown. I think the last thing I posted was 5 years ago, so I'm just gonna post what I want. Ha ha ha. And today we're gonna learn how to get pixels quickly in Java. And this is hint hint not using get RGB, though I do have a comparison coded out where we have get pixel array slow, and it does use buffered image.getRGB, and then we have a faster one that I will code along with y'all if y'all want to follow along. Otherwise, I will just watch. So far I have a bunch of code already here. This is creating a JFrame. This is just going to be to display the image because after we get the pixel array, I have a function that turns it back into a buffered image so that we can display it and prove that like we do get all the pixels from it. Otherwise, we'd just be looking at an array of integers and crossing our fingers. So I'll show that so that we can actually see. Um, Here, that's just the helper function here. Uh, this is the slow one, which just gets, calls get RGB using a array of pixel values. Uh, and yeah, let me see what else. So far, right now, this also is a huge bottleneck, image.io or image.io.read. Um, I can probably look into how to speed this up, but so far, when reading in large files, getting the pixels actually takes a lot less amount of time than actually reading the file. And I'm assuming it's probably because reading is doing something in the background. So maybe I can go into a future video discussing a faster way to do this as well. The reason I actually started looking into this was because I was writing a program. So I don't know if you guys know, there's a program called PyWall, which is I have Ubuntu on my laptop that I kind of mess around with a whole bunch, and I use PyWall to help make my wallpapers match my terminal theme and vice versa. So if I had like a purple terminal, it would make my background purple, or if I had a purple background, it would make my terminal purple. Um, could toggle between, I believe. Uh, but that got archived, and and also I think I updated to the newer Ubuntu version, which is like Noble Numbat or something, and it stopped working. Probably because I'm just bad, but besides the point. So my friend was recommending GoWall, which is pretty much PyWall written in Go, supposed to be a little bit faster. I think it lacks a few of the features PyWall had, but that's understandable. I think I have it pulled up. Uh, so here we go. Basically, you could give it a image. You have a theme that you can have in a config file, and then it could change the colors of that. I wrote my own version of this called jawall, just because since we're adding the first two letters of all these languages in front of the word wall, thought I'd do that. And it was a fun project. I really enjoyed it, and I learned a whole lot from it. But uh, in order to, I guess, get the pixels fast, and I also wanted to edit them and replace the image. Uh, I was looking into how to do that, and originally I was just planning on using get RGB, set RGB, but apparently that's very much not the way that you should be doing it. Though you do have to kind of weigh the scales of this is a lot more readable than what we're going to write here. We're going to write a bunch of stuff here. This will be more performant, in some cases more than twice or even 3 or 4 times as fast than this. So it depends on how often you're going to be needing to get the RGB values from pixels. Um, if it's something that you program needs to frequently do, this is probably the way to go. If it's more of an infrequent kind of occasional thing, then honestly, 3 lines definitely beats what we're gonna write here. But I believe I went over everything. Let me just double check. So here we just have we get the current time milliseconds, then we run the function, then we output the time afterwards, and redo it for the slow one as well, just so that when we run the program, we can see the millisecond time for each function to actually see if the fast one is faster than slow. And then the proof of fast is getting a buffered image from the arrays that get returned, and then we can display with them. Right now, I'm displaying one. I'll probably swap that out for the slow one just to display that both are the same image. And right now, we're using 2 images. So I'm going to start using this wallpaper that I got from wallpaperflare.com. Uh, and then secondly, we'll use this image of a door. And originally, it was actually kind of funny. I used this because I was like, oh, you know, for my program, that's kind of like a GoWall. I was like, this has a bright yellow color. I feel like this would be an easy one to just like, you can swap out the yellow if I wanted to make that a blue and then make the, white something else, and it just had a lot of colors that kind of popped. But I feel like since they were so like contrasting, that you could also swap them out kind of easily. I very quickly learned this is actually insanely. I think if you can see up here, 4,640 pixels by 6,960 pixel JPEG. It's 4 MB. This one, however, is just 1920 by 1080 JPEG, 1 MB. This one takes an insanely long time to for image IO to read. That's where I actually realized that was a issue. Um, and also just takes a long time for to get the pixels from it. So that was kind of fun and interesting, and made me realize that maybe I can make this video for anybody who may have image processing issues or questions. So let's get started. I believe so if you don't know what JFrame does, we're just adding the image and then we pack it. Oh, get rid of that. And then we make it visible. JFrame is just pretty much a window. And I think I have explained pretty much everything. Okay. So to get started, there we go. Let's go ahead and so we're getting our image. Let's go get a byte array of so this is going to be a little bit misleading. I might explain this a little bit before I start typing because I am not great at typing while explaining. Uh, we're going to basically get a array of pixels. So I guess that is the confusing part. So they're not actually going to be pixels. They're going to be ARGB values. So alpha, red, green, blue, stored pretty much in that order. So you'll have alpha followed by red, followed by green, followed by blue, and then it'll be the next pixel. So I guess every 4 values will be 1 pixel. I don't really know what to call that. I could just call it a array of values, but I feel like that's also very vague. So I'm going to call it array of pixels, even though each individual byte will not be a pixel. Also, if the picture does not have an alpha channel, which I believe neither of these do, it's actually just going to be 3. But I will show y'all how we can worry or fix that. Worry about that. So alpha by pixels, and then we can. I just want to clear that up. So we want a data buffer byte. There we go. Then we want to get the raster from the image. Get raster, which basically contains some of the image data. There's also a color modal or model, sorry, that you can use to get some other information. Honestly, I would have to look at the docs to verify what information is stored in each, which I'll probably do after this to go see if there's a way I can read in images faster, but I feel like that would involve some nasty stuff that I honestly don't think I want to care about. Let's do get width. Oh, wait, it's like we actually have the width and height. I'm passing it already. Thought about that ahead. Let's do a boolean of has alpha channel. Dot get alpha raster not equal null. So that'll just check if it has an alpha channel, and then honestly don't know if this is super needed, but this is kind of what I was talking about earlier, where how it has variable length pixels. We can do pixel length. We can go to image dot get color model, and then get pixel size. There we go, and then divide by 8 because it gives you the pixel size, I believe, in number of bits in a pixel. And then you divide by 8. So let's go over here. So that says 24-bit color. So that would be 3. So yeah, each of these are 24-bit color, 24-bit color. So sorry, I didn't really think about this ahead of time, but it didn't really matter too much because the code pretty much does the same thing. Let's go ahead and do, have a result that we're going to return. Equals new and then height times width. There we go, and then return result. In between all that, we're doing if has alpha channel. Dang it. Sorry. Not really too used to typing on my desktop, but we'll live through it. There we go. So let's start out. since we don't have an image that really does the alpha channel, we'll save that for the end. The code is pretty much copy pasted except for one part. So let's start out with we're going to define a bunch of variables and pixel equals 0. We're going to do, oh, sorry, not semicolon, row equals 0. Column equals 0. Oh my goodness, there we go. And that is the last one. Then we do pixel plus pixel length minus 1 less than pixels dot length, and then pixel plus equal pixel length. So basically, again, we're gonna replace pixel with a value. I feel like that would be a good thing here that we can do, because again, each individual I guess item in this array, or each individual byte, is not a pixel itself. It holds the value for the alpha, or that A, R, G, or B. So I feel like labeling that as pixel would be a little bit misleading. Let's also talk. So I already mentioned pixel length. That will probably be 3 or 4. 4 if it has the alpha channel in it. It'll be 3 in this case, and 3 for the cases of the 2 images that we do have. But that should not be an issue. ARGB, we're going to set it equal to 0. So if you've noticed, we're returning a array. It's just a one-dimensional array. If you want, you can do this and make it a two-dimensional array. I believe the functions that we are dealing with image.getRGB, and I believe I think that might be it. I guess we're using array copy. I don't know. It just seems like it'd be a little bit more work, and also when you do the slow method, getRGB does return just a one-dimensional array, and then if you set RGB as well, it returns one-dimensional array. So we can go over, I guess, how that is stored, but it's pretty easy. Oh, so sorry. Here, ARGB, we're ORing it with a all one byte, or a byte of all ones, but we're shifting it 24 spaces over. So I was debating on drawing an image for this. I guess we could do it here. 7, 8, boom. So this would be ORing the first 8 bits with all ones. So that would be sorry, I didn't count. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It'd be turning the first byte into all ones, pretty much saying that the image is opaque. Then RGB, or ARGB, we OR the next bit. We're going to do this. Then pixels value. This will be the blue value. We want to bitwise and with all ones. And I forgot why we do this. I did have it written out. Let me see if I have my explanation somewhere handy. I think I deleted it. But I do know if you AND it with all ones, I believe the result is different than if you don't AND it with all ones, though I believe, not sure why. But basically this is getting pretty much the binary value of, oh, I believe that's why. Because otherwise it's storing just the int versus the binary value of the int. Basically, it would return a negative number if it has a 1 at the beginning, I believe. Not too sure. But I did do it both ways. They return different values and give you different results, but this is the way that I believe is correct. And then here, oh, sorry. So this is blue. Blue, since we aren't shifting the bits at all, it'll be 1. That's tedious. We're actually saving blue for last. ARGB or equal pretty much copy this, except you want to shift it over. Let's go starting with 16. We're going to descend in how much we shift. We want to, I believe, surround that in parentheses. I believe that is correct. This will be green. This is because with psych, that's red. What are we talking about? This is the 8 bytes that follow the alpha, so it'll be 1, 2, 3, 4, 5, 6, 7, 8. These bytes, or bits, sorry. In this case, we're going to do 01, 01, 01, 01. Gee. So I guess we'll copy that for here. Then this will be, that still is blue actually. Delete that, copy that, paste that there. Make this 8, shift it over 8 bits. We're shifting it to the right, by the way, or to the left, which is what those double arrows mean. So we're going 8 bits to the left, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So these bits right here, we'll get this. We're going to have this, I guess. So last time we did 1, 0, 1, 0. We're going to do 01, 01, 01, 01. Oh, I guess. No. Psych. There we go. Sorry, I was trying to match the links here, but this one starts earlier. This could be green. This could be blue. And then the final 8 bytes 1, 2, 3, 4, 5, 6, 7, 8. And these are just made up values I'm just doing for, I guess, the sake. So we're going to have that 1, 2, 3, 4, 5, 6, 7, 8, all ones again. Basically, this is what the ARGB value will be looking like. But of course, returning it to an int, or I mean, so I guess this binary value would return to an int, which would be some really large value. But I believe that once we turn this, give this to here, the buffered image, it knows how to parse that and get the actual pixel values from this. If you want to get the pixel values from it, I believe, honestly, that might be where this, I started using it. Maybe not. I think you would, instead of or equals, you do and equals with a bunch of ones. Again, should have kept my notes around. But boom. Then you want to do your row times your width, plus your column. Have that equal RGB. So this is because, so if you're on the first row, that zeroes out. You have the column, which is, 1, 2, 3, 4, as you go along there. Imagine, I guess, a two-dimensional array, but then, I guess, let's say it's like 100 pixels wide, or 100, I guess. No, yeah, pixels wide, I guess. But you're on the first row, or yeah, so this would be 0. Then you times by 100 is 0 plus whatever column you're on. When your column reaches finally the end, well, I guess let's add a logic to that. Column plus plus plus. I was getting a little confused. If column equals width, then we're going to do column equals 0. And then row plus plus. But yeah, so we set the result equal to RGB or ARGB. Basically, when the row is now equal to 1, instead of going in a two-dimensional array, you'd go to, I guess, the second array that's stored in there within the array. You would then go the whole width value, so then you'd that'd be 1 times 100, which would be 100, then plus column, which would probably be 0 at that point, which prior would be 99. Psych. Or no, yes, it would be 99, which then gets incremented to 100, which then equals the width. There we go. And yeah, I think this is all for the non-alpha channel. For the alpha channel, we're copying and pasting, and then we are going to probably we need to do the exact same thing, except instead of here, we want to copy paste that. Oh, there we go. Found something else that we did not do. Shift the value over. So blue is the, I believe, first. Psych. Alpha would be the first up in here. Oh my goodness. I've confused myself. Let's go back down. Get this code right real quick. There we go. For green, it is +1. I have the code pretty much written in my repository over to the side that I'm referencing, just because I don't want to try to explain things. Well, I am losing track of where I am, but it is probably would be worse if I did not have this reference. And then we're going to go back up here. So this basically, you're moving over your values again. Since these aren't pixels, it's technically not an array of where each index is a pixel. But when you combine the values, it is the values of a pixel, I guess, which justifies that name and then this name. Uh, and in this case, since there's only 3, we set this. It's always going to be 255 or byte of all ones. And then that looks good. And then I might snag this again. Drop it up here. Eat that. Boom, boom. This is going to be 24. Same shifted as here. Except I believe that value comes first. That value comes second. That value comes third. That comes fourth. I believe we are all set and ready to rumble. Let me do a quick scroll, compare it with my notes. Or I guess my code. If I had notes, I'd probably be explaining things better. Which, by the way, if you do have any questions, reach out in the comments, because I'll definitely be able to, I guess, think through it a little bit harder and can hopefully get back to you. I think we are all good. So, again, let me take a look. Get pixel array. So we have the buffered image that we read in through image.io, get that passed in along with the width and the height. Then we go through, determine if that is an alpha channel. If it does, it has 4 bytes. If it of values. If it does not, it has 3. And the reason that we do the if statement outside of the for loop, I believe, I mean, that's just the way I kind of did it. And I did think about swapping it inside, but I don't know. I believe it would probably not be too big of an issue, just because since it would be the same value every time depending on the image, because like the alpha channel won't change mid inside the if statement. But instead of, I guess, having 2 for loops, you would just have 1. Uh, and I believe the Java JVM would optimize that to where it wouldn't really cause any like performance issues. I don't know. I just wrote it this way. I guess to help emphasize the difference that here you do set an alpha value, and it's the first pixel versus or the first value in the pixel array versus here where you set it as a constant. All right. I think we're ready to run the program. So what we're expecting to get a console log of the first time we see will be the time in milliseconds of the fast program. Second is the time in milliseconds of the slow or the fast function, which again, as you can see, not very readable. But if you are prioritizing performance over readability, maintainability, I think this would be good. If you write that and leave it alone. If images aren't really what your program is meant to be handling, then I think this would be fine. And of course, there's probably definitely better ways to do this, but this is just something that I was figured out and decided to roll with. Uh, all right, but yeah, and then there should be the image, which I think the first image we're starting with is the wallpaper. Should pop up in a JFrame to prove that it looks just like this. And so let's go. That does not look just like that. That does actually look really pretty though. We are gonna get rid of that. So we did see it was the fast one, although incorrect as of now. Uh, did execute faster. Let's see what is up. So this code is not executing, so we don't need to worry about that. What is happening here? Let me scroll over to my notes, but also let's just look at this and see if we can determine. Oh, hmm, okay. Yes, this is red, which comes last. It's actually blue that comes first, and then green stays the same. It's BGR. I say that like I knew it. Or wait, yeah, BGRA. It's reversed. Same here, how we shift it 24 over here. Well, no, the shifting doesn't matter. But I guess we could double check and make sure that's all good, which it probably isn't because we just swapped it. Alpha does actually come first. It's a BGR, which I also can't really explain why that is the case. Why it's stored in BGR instead of RGB. But this should be the fix. There we go. Let me maximize that. Swap over here. Wrong image. There we go. I believe those look the same. Now we're going to do this, which is the beefy one that I was threatening with earlier. Let's go get the path from content root, swap it out for here. Stop the program. So that was 11 milliseconds compared to 51 milliseconds. I did notice though when I was transcoding some or videos, it was using a lot of my CPU, and I was trying to run this at the same time, and the slow one was actually running faster, which had me scared because it was right before this video. But so that might be something where maybe it's, I don't know, multi-threaded. I have no idea, but where something there's like something more going on where I guess if your CPU is not under a lot of load, uh, probably it slows it down. But if it is, then it speeds it up. Where it pretty much was, I guess, flip flopped ratios, where the faster one was like faster by or slower by a little bit of a not an order of magnitude, but same kind of ratio. Um, okay, so we swap the image, and then let's do it now. So this is going to take quite a while, but the majority of time here is actually right here with the image.io.read. I think I mentioned that earlier. And if I can figure out a better way to do that, yikes! So as I said earlier, it is like 4,000 by 4,000. We can't really see the whole image, but I just scrolled it past the screen, or it's still scrolling. There we go. And then, oh, can I squeeze it up? No, no, that's fine. So yeah, as you can see, the bigger the image gets, the more dramatic the difference gets. Um, so if you are dealing with, I guess, large images constantly, or high quality, high resolution, uh, this also might be something you should look into. Uh, oh, so right there, we were just showing the proofs of fast. Let's do proof of slow, since my first proof of fast was also incorrect. Uh, so we're going to start with this since we have it up already. Um, so yeah, this time before any of the time sprint. There we go. That's just all image IO time. So here's the slow one. Oop, there we go. Ah, oh my goodness, fumbling that. There we go. Huge image, just like before. And then we are going to do something that we can actually see a little bit better. Copy the content root, and boom. I can post my Git repo where I have my jawall or Java wallpaper pretty much theme changer. Honestly, it's more of just a thing I personally use. It's not fleshed out at all. It's very not a lot of options. Definitely, I would recommend using GoWall. But I guess in order, if you I program a lot in Java, so if you find reading Java easier, then you can go reference that for this code. And here's the image. It is the same. Let's go back just in case you think I'm a liar. They're real. And so thank you all for watching. Let me know if you want to see more content like this. This is just stuff that I was diving into recently and wanted to share. So thank you for watching.